Hey guys, and welcome to Functional Print Friday. So what I've got on the bench this week I think is going to be the start of a pretty cool project. I was helping out a friend with some networking equipment that had stopped working. It was a 24 port power over Ethernet switch that it stopped injecting power, and I had brought it back here to my bench to see if I could figure it out, and ultimately it wound up being the daughter board, the part of the board that negotiates the power over Ethernet connection and then sends it down the line, and it wasn't worth replacing. So he got a new switch, and I kept the old one just to scrap parts out of before I threw it out. And I kept some fans and some other stuff, but I think the most exciting thing in there was this power supply. This guy is rated at 53.5 volts DC and 4 amps. So it's a little over 200 watts, which is a good bit of power. But what's particularly interesting is that it's so high, and this makes sense. Power over Ethernet I think it's 48 volts. I'm sure somebody will correct me down in the comments if that's not accurate. So this guy is going to be a higher voltage than that because there's going to be voltage drop across the wire. And 4 amps is, again, it's quite a bit. I mean, even if this was a 12 volt power supply at 4 amps, I'd be happy to have it in my stash. But being such a high voltage, I got an idea for this. All right, so I looked at these a while ago on Amazon, and I think I still had one on my wish list. I never pulled the trigger because this is a bit misleading here. It says DC power supply. It's not really a DC power supply. You don't just get DC power out of this by connecting it to, say, a wall outlet. You've got to feed it DC power at a higher voltage, and then it will allow you to basically output whatever voltage you want as long as it's, I don't know, I think 10% less than the input voltage, which is why I'm excited to have this power supply, because being such a high voltage, we should have quite the range of power output options on this guy. If I'm understanding how this works correctly, we're going to test everything before we start doing any design work and make sure that this is going to do what we think it is. But in theory, since this is, say, 53.5 volts and 4 amps, we should be able to get a much higher amperage out at a lower voltage. So at 12 volts, we should be able to get, well over 10 amps out of this guy. In fact, probably quite a bit more. This is actually rated for a crazy amount of current, but I've just learned that in general, stuff from China is not going to perform at anywhere near its rated outputs. These have a pretty good following. A lot of people really do like these Riden units, but I bought the biggest one, the 6018W. This is the highest output rated one they sell. I think it's rated at like over a kilowatt of power, and we only have, I don't know, like 215-ish watts to work with. So we are going to operate this guy at 25% of its rated output, which is probably a good thing. It should last a good long time. But let's open this up and see what we have in here. By the way, I paid for this with my own money. This is not a sponsored video or anything like that. I keep saying it, but not that I'd be opposed to getting anything for free and giving it my honest opinion, but power supply I got for free because it was going in the garbage, and this I paid full price for. That said, full price on this was a really good deal. I don't know if they're still on sale. I'll put a link in the description to this guy. Again, like I said, I bought the highest end model they had, the 6018W. I think the W stands for wireless. I believe you can interface with this from an app on your phone with either Wi-Fi or Bluetooth, or maybe it's just Wi-Fi. I don't remember. And there's also a PC app as well that you can connect to this guy with USB. But this was, I want to say, like 85 bucks, which, if this thing does what it says it's supposed to do, is really quite the steal. So I know it's hard to tell on video, but honestly, it looks pretty nice. It doesn't have that sort of flea market, every single corner cut look and feel to it. It actually, it seems more in line with, say, at least my Riden oscilloscope. It's pretty heavy. A fair amount of capacitors on the back, which is probably adding to the weight, as well as these cores here on these inductors. And we're missing something down here. Looks like a temperature probe, maybe. Okay, that's what we're missing in that spot. This looks like the, they probably the only difference between ordering the 6018 and the 6018W is just whether they include this in the box. This looks like just a Wi-Fi add-on board. Sort of looks like one of those little expressive, yeah, ESP. Get it out of the bag, probably easier to see. Yeah, ESP-12F, it says on there. And I'm guessing this probably plugs in. Yeah, it's going to plug in down there. We're missing a battery, though. That looks like maybe a spare fuse. Oh, yeah, there we go. Or maybe we have to put that in. I'm not sure. It kind of looks like we have a fuse here. Maybe this is a spare if you blow the onboard fuse. But there's no battery. Let me take 2 seconds and look at the instructions. Okay, so you don't get a battery. I wish I knew that. I would have ordered one. So I'm going to be back in here, I guess. This is not a very common battery either. I have probably 6 or 7 different types of watch cell style batteries, like these small lithium coin cells, and none of the ones that I had in my stash are the correct ones for this. So I guess I probably should have read the description better. Hopefully we don't need that for this guy to work. My guess is that's probably just for the clock. And should we wait on now? Well, let's put this in. I really like how that sits in there. That might not be right. I wonder if we have to take this board out to put that in place. Like it's just touching the, you guys see that? It's just like, just pressed up against the rest of the board there. Like I don't know that we're shoring anything out, but. Okay, I got that to seat down a little bit further. Now it is basically the top of it is flush with the top of the other circuit board, so that makes more sense. But I don't know how I'm going to get it back out. I guess I could push on it with a screwdriver from here because we've got to get that back out to put the battery in at some point. Okay, it looks like we have a power input on here. And if I recall, I think this thing's actually rated for a higher voltage input than what that is. Not by a whole ton. I think this is rated at 60 volts, if I remember correctly. So let me fish around and see if I can come up with some wiring to get this attached so we can test this. I'll link these things down in the description as well. I use these all the time when I'm messing around with electronics like these. These are Wago or Wago, I'm not sure I'm pronouncing that right, connectors. They are a little bit pricey, but they're reusable. I probably wouldn't use these in an electrical box the way that they're intended if I could avoid it, since wire nuts are way cheaper. But because these things just cam up and down to lock and unlock the wires, they're great for stuff like this because the wires slip in far enough that you're well insulated, so you're not going to hurt yourself on the high voltage side. But they lock in really nice. So when I took this apart and I cut these, I marked them because we have a red and a black wire. But from how it looked like it was wired to the power inlet on the back of the Ethernet switch, this one looked like line and this one looked like neutral, which I guess if we have red and black, red might make more sense for line. It's just weird because at least here in the United States, on single phase, the black wire is generally your line wire. So this might be a short video. All right, let's do one more idiot check here. So line is coming up to our hot lead, and neutral is coming up to the one that I've got marked neutral here from our power cable. All right, yeah, I feel like I should stand back. Okay, I plugged it in, nothing went pop. There was like sort of a high frequency sound when it first turned on, so I think it's on. Let me get a tester, let's check. See, we went DC. And it looks like 52.1 volts, which is a little bit less than what it is rated for, but it should still be plenty as long as that doesn't drop. Actually, you know what, since we have no load on this, that might even stabilize when we start to put a load on it. But looks good. Also, worthy of noting, generally anything below 30 volts is considered low voltage and safe. Over 30 volts is enough to shock you, whether it's AC or DC. In fact, it can be worse on DC, so do be careful if you're duplicating this project, particularly if you just have a bare transformer like this. I mean, we obviously have line voltage on one side, so like I can't pick that up on the bench right now because all of the solder joints on the other side that are on the line side are going to be hot. But even the DC output at 52.5 volts is enough to shock you, so be careful. All right, fingers crossed. That was scary. You know what, maybe I'll unplug the power supply. I think that was just the the current arcing across the connections there when this guy powered up. Probably the capacitor's powering up on this guy, but I'm gonna unplug that. Plug this in and then we'll plug that back in. Okay, I'll set this so you guys can see it when I plug it in. I'm going to try to anyway. Okay. That looks like it's working. All right, well, if you haven't figured it out yet, this week's functional print is going to be a case to tie everything together here. Because while we can test it on the bench like this, I already said I can't touch that guy. We're only safe because this is a wood workbench, so we're insulated. And I got to be careful not to touch the back of this as well. But if this works the way that I hope it's going to, what I'd like to do is design a nice compact case that both of these things fit into, probably some auxiliary cooling, because the network switch that guy came out of did have active cooling in it. It had a fan that ran all the time. And I'd like it to look good too. I already looked, and there are a couple cases out there that folks have designed for this, and there's just sort of a long metal case that they sell as well, that the company Riden sells. I'm not a big fan of the looks of anything that I've seen. I mean, to me, this unit itself is actually really nice looking. The build quality on it so far from what I'm seeing is really good, but you pop it into, just like like a project box case or like just a long metal case, and well, it looks like a project. I don't want this to look like a project. I want this to look like a finished product. Like if this was the front end of a high-end DC power supply, that's what I'm shooting for. So let's get back to testing this, make sure it does what we want, and then we'll get into the design. All right, so I'm trying to get everything in frame here. Just as a starting point, I'd like to see what we get out of this from a voltage range. It's actually giving us the input voltage here up on the top of the screen. Hopefully you guys can see the screen at the angle the camera's at. It's kind of tough because I can't really lean this guy back any further. But it's telling us that our input is 52.35 volts. I think our on-off is our output. Okay, so it looks like we're outputting 49 volts. I don't know if that is, quite frankly, I just don't know what I'm doing with this because it's my first time using it, but okay, so the voltage is set all the way up. I'm adjusting the voltage right now. We're at 51.24 volts and we're only getting 49.184 out. So I think that's as high as it's going to go. Remember I said that we're not going to get the same amount of volts out that we're putting in. There's going to be some loss there, but that's actually pretty close. 49.18 versus 52.34. So then if we go down with this guy, got to be a, there we go, make it a coarser adjustment. Okay. Yeah, so now our output voltage is changing. So let's set it to 30 volts. And I'm reading 30 over here. So that's a good sign so far. Let's try 20. It's flipping back and forth between 20 and 20.1. Set it at 5 volts. This Fluke 337. This is not what this is designed for either. I should probably go grab a better meter to test this. This is a clamp meter really designed for reading AC and DC current, but it's good enough for this. 40 volts. I wonder if we could just type in the voltage. What happens if we just type? Oh yeah, look at that. We can just type it in. I assume I can do that in a granular fashion too. So if I wanted like 12.57, oh no, we're not on there anymore. Oh, we got to hit the voltage set. Yeah, look at that. That's pretty cool. This is already, this is way nicer than the bench power supply that I have, but we also haven't played with any of the other features yet. I set, is that our current? Okay, so it looks like we have the current set at 3 point some amps. So in this case, just having a meter hooked up, we're really not drawing anything, which is I think why this is all zeros. But if we actually had something connected that was drawing current, we would also be able to control the amount of current that's coming out. Now this is the part that I want to test to make sure that this is going to do what I want. Is we should be able to, even though this power supply only puts out 4 amps, at a lower voltage, we should be able to put out a much higher amperage. Okay, and this is a success with the car battery tester. Unfortunately, we're not going to be able to actually see the total rated output of this guy. We should be able to get to probably close to 200 watts. I don't know, maybe 180, 185 watts on the output side here. But this is a resistive load. So the constant current's kicking in. So we're only going to get up to, in this case, 3.13 volts at our maximum amperage that we can set on this guy. But still, this proves the point. So we're outputting right now, we're outputting 18 amps, albeit at 3 volts, but we're outputting 18 amps from a power supply that is only giving us 4 amps on the output side. And in fact, we're not drawing anywhere near 4 amps. We're probably drawing, well, you know what, we could check. All right, 1.3, 1.4. Does it zero get? Yeah, it does. Okay, so let's try 1.35. 1.35 times, I think we had 52.2. So we're drawing roughly 70 watts from this guy, and we're seeing 57-ish over here on the output side. That's not bad. This guy does all sorts of other cool stuff too. Unfortunately, I don't really know how to use it yet. By the time we get to the end of this project, I'll probably be able to give you guys a better demo of what this thing will do. But, yeah, there we go. Now we have a graph. Yeah, so it'll actually graph our output as well. So now if we, let's see, if we set our current down, so we're just artificially adjusting the output here rather than adjusting the amount of load on this. But if we had something attached that had a varying load, we'd actually see that on the graph here. Instead, what we're really seeing is just the result of me adjusting the output. But you could see, I mean, you know, it's not going to give you the same functionality as like an oscilloscope. But I could see for a lot of loads where you want to see what maybe the peak current is and what the usage looks like, or maybe for battery charging, that's pretty cool. And we might be able to switch it to, actually it's probably, I think it is showing us voltage down at the bottom. It's just it's so low, it's just basically at the bottom of the graph. All right, enough messing around. I do like geeking out on electronic stuff as well. Sorry if I was putting you guys to sleep. Hopefully some of you guys found that interesting, but let's get this cleaned up and figure out how we're going to design a case for this. Okay, so here's what I'm thinking. I want to be as minimalistic as possible, but not pack things in so tightly that we can't service it or move air around in there either. The shape of this, we probably could stack them like this, but I think we're going to have a challenge with airflow because I don't know how we're going to move air from the back of this board around. Even if we put things like this, I think we're still going to have an airflow challenge. What I'm thinking we do is maybe position this like this instead. That gives us some room to work with vertically inside of a case. And maybe we have some room behind, well, you know what, we're going to need a power inlet as well. So we're probably going to end up, I'm thinking like this. So we have this guy, we have this board behind it, we have room for a power inlet and maybe a fan. What else am I missing? It'd be nice if this guy was at a bit of an angle. I didn't really spend too much time testing the viewing angle. In fact, we didn't even peel the plastic off here. But we probably don't want to be looking directly down at this guy. So it'd be nice if the whole thing naturally had a bit of a tilt to it. So maybe more like that. And maybe we have access from the bottom because, yeah, if we're like kind of long in this direction, but not very tall, it's going to be difficult to access everything from just the rear. So maybe we have access in the bottom. So maybe actually we have this guy upside down like that. That would probably work pretty well from an airflow perspective because, so our side view then would be kind of like this, right? So if this guy's at the top, we could have air coming in maybe from the bottom. It would flow across our components here, get the heat away from whatever this fan's blowing on, and then draw it up either out of the top. Well, no, because we want to put the fan at the back. So, well, that's all right. So it's still going to draw air from the bottom. Maybe we have some standoffs so that this guy's not right at the top, so air can flow around both sides of this and then out of the rear. Let's fire up SketchUp and see what we can come up with. The other thing I'm thinking of, really it's important to me that this guy looks good. Like I said, there's already a couple designs out there for this, and I'm not saying anything negative against the people that designed those. I'm sure they're perfectly functional. I've always wanted a really nice high-end bench power supply. They're like $600 for a decent one, like for one of the Riden branded ones, or otherwise. This thing does 90% of what those do, but I want it to look good. I want this to look like a much more expensive piece of equipment on my bench than it really is. I mean, I've got, I think, $85 invested in this. This was free. We're going to need some other pieces. Actually, let me go check my stash and see if I can come up with a fan and a power inlet. Okay, I've got a fan. I don't even think this one is used. It's a 3-lead fan, so one of these would have been a speed sense, but we don't need that. We can just chop that off. The one challenge is this is 12 volts. We might have 12 volts out on the fan connector, but it specifically says in the manual for this guy not to connect anything else to our fan output. So I guess we probably should heed that warning. And I didn't see anywhere else on this board where there was like a constant output of a lower voltage. And we can't connect the fan to the front end because that voltage is going to vary. I also probed around and I didn't find anything on this for a DC output other than our 53.5 volts over here. So I think we're actually going to need a second power supply just for our fan. But that's okay because I've got that figured out already. On the project we did for the timer base on the Heiko soldering station, I had picked up a 2-pack of these. And this is a tiny transformer that is, it's AC, it's single phase AC at 120 on one side, and I think 12 volts. on the other side. Yeah, 12 volt, 1 amp version. So this is line AC on one side and 12 volts, 1 amp on the other side. So that should take care of our fan. And I also found, I had a bag of these power inlets that I'd bought for another project. This should work for our power inlet and switch. So I'm thinking we have this on the back. You'd reach around the back, flip this guy on. That'll dump power into the input side of our high voltage power supply and into the line input side of this. So our fan will turn on, it'll turn this on, and then we can, well, this guy will be on. Our button, I imagine, will be lit, but we'll hit the button to turn the front end on. So, all right, let's get designing. All right, and here's where we are so far with this. I'm gonna stop at this point here and do some test prints because I'm investing a lot of time in this and I wanna make sure that things are gonna fit together and function the way that I'm thinking before we go much further with the design. So far what I've got is just sort of a rough bezel here on the front that has a recess in it so that we have a little bit of stick out from our power supply. That's on purpose. I'm hoping that we just kind of get some visual appeal with the shadow line there. And then I've sloped the case back, which I gotta say was really kind of a pain in the butt. Well, it wasn't a pain in the butt to slope it back. I'm realizing now though that because nothing is straight, that it's gonna be a bear to do the rest of the design work on this. But I don't wanna give that up. I think the sloped case is important. That gives us some setback here from an angle perspective for the front panel. I'll probably still end up doing some sort of feet or maybe even fold down feet on this guy to prop up the front even further. But even when this guy is now sitting flat down on your workbench, it's got a couple of degrees of tilt back in the front, which I think is not only going to be a lot easier to read the screen, but I think is going to give this guy more visual appeal as well. Thanks to user Spooder, S-P-U-D-E-R, on printables, I actually didn't even need to draw the power supply, the Riden unit itself. He had this model already generated, so I was able to work from that for my design. And you can see now the recess here in this bezel that this guy drops partially into, so that we don't see sort of this section here, but we do see this section of the front panel of that unit. I'm also kind of have to give a lot more thought to how these pieces fit together. Like right now, this is really more visual mock-up than anything else. I'm probably going to want a shadow line between these two, and I'm going to want to be able to mate these two pieces together without any visible fasteners. So there's still a lot of dots to connect, but I think this is sort of the rough shape. As I mentioned before, we'll probably do an access panel on the bottom, as well as a separate panel on the back. Haven't given a ton of thought as to how we're going to do that yet, but I'm liking the bones of this. I think this looks good just from a, from a starting point perspective. So I think I'm going to stop here and I'm going to print this bezel out and not only confirm that our power supply unit actually fits into it, but also just see how it looks. So let's slice this up and get that printed out. Okay, so I completely forgot to turn supports on, and somehow it still managed to kick this guy out. It's obviously an ugly mess on the inside, but it managed to just pile up enough filament to end up with a solid top surface. We're even solid in here on this step, so let's try it out. And it doesn't fit. So I had measured this down here at this end, or at least I measured in the middle. This might bell horn like out a little bit or something, because I mean I can see just lining it up. We're close, Yeah, I can force one direction in. Yeah, it gets tightest at the end. And I can, yeah, that's even tighter in that direction. All right, well, this is also not clean anyway, so let me go fire up another one of these. Okay, so I remembered to turn supports on this time, and they came off really clean. And I also made an adjustment to the front bezel and the design. Looking at this, it's, you know, it looks good. I actually really like this this matte blue filament as well, but it doesn't look expensive enough. So I went and I looked at some of my electronics toys, and a lot of them have sort of like an inset here on the side that sort of just gives it some shadow lines and just sort of sets it off a little bit. And actually really like the look of that. I'll probably have to add some more to the mesh, a little bit more detail, because I can actually see our triangles on this. And that's not quite the look I was going for, but I do like sort of the inset there on the side. I like the way that sets it off. But does it fit? I think I adjusted it by another 0.2 millimeters in each direction, and that's a really nice fit. Locks right in. That looks good. Really happy with that. So this is set part way in, but I left it with a little bit of reveal. So again, so we kind of pick up some of that shadow line out here. It's those little details that go from looking like you know, something you whipped up in 5 minutes to something that's an actual, like, really high-end product that you're going to buy from a store. Okay, so this is looking really good, but I think we're going to stop the video here. This video is already getting pretty long, and I gave some thought to how I'm going to have this bezel key into our main body, and the design that I started on is not going to work. I like the overall shape sort of that we have working for that main body. I like that it tapers back. But I need to think through how we can get this bezel to securely attach to the front. So either snap in or have screws that go in maybe from the inside, because I don't want to see fasteners on the outside. I'd like to have a small gap here, again as a shadow line where this keys into the front. So we have sort of like a little bit of a gap between the front and the body. But in addition to thinking about how it keys together as a finished case, I need to think about how all the parts are actually going to 3D print. And I didn't think about that for this top edge. As I've drawn it now, it's not going to work. I need to adjust, I think, the design in the case and probably the design on the inside of this guy as well. We'll need something for screws to go into. And we haven't even gotten started yet on the back panel that's going to have the fan and the power inlet. So that's going to be next week's video. I'll keep it to 2 videos. This isn't going to turn into a huge project. But I think it is worthy of 2 weeks. And when we're done next week, we'll have this guy all together, all wired up. We'll test it, and I will share all the design files with you guys. Guys, as always, thanks for hanging out in the shop with me for this week's video. It's really a pleasure to put these videos together and share them with you guys, and I really appreciate all the comments that you guys leave me down below. This channel is reaching, I think last time I looked, I'm almost at 2,000 subscribers, which is just, you know, on one hand, I'd love it to be 100,000, right? But on the other hand, it's pretty amazing that there are, you know, 2,000 people or almost 2,000 people that are really into functional prints and enjoy the format and style of these videos. So guys, as always, thanks for tuning in. If this is by chance your first time on the channel, we do a new functional print every week. I give away all the STLs and design stuff for free, and it's always something functional. We don't do any like multicolored benchies or anything like that. So if this is your first time here, hopefully you'll hit that subscribe button. And guys, if you do, I'll see you next Friday.